Hello, everyone, and thank you for joining us today for this session. This is Ops 302. We'll be covering monitoring as code. I'm honored to have Pod Sandhu from the Schlumberger SRE team here with us today. Later in the session, he'll be discussing how his team and others at Schlumberger implemented the practice of monitoring as code. He'll also get into some lessons that they have learned in this journey that we think you could benefit from as you start yours. Pod, thank you so much for being here today.
No, thank you, Yuri. It's a pleasure to be here.
My name is Yuri Grinstein, and I'm a site reliability engineer at Google Cloud on the customer reliability engineering team. So here are the topics we'll be covering today. We'll start by understanding the basics. We'll define the concept of toil as it relates to the practices of site reliability engineering. From there, we'll cover the objectives of as code practices. Next, we'll review the specific Google Cloud monitoring entities that can be automated and compare 3 approaches to automating them. I'll wrap up the first portion of the session by showing you a couple of specific examples of automating cloud monitoring entities. From there, I'll hand it over to Pod to cover the lessons learned at Schlumberger as they have pursued this in earnest. Let's get started. So first, what do we mean by toil and why is automation important? Well, if we go back to our fundamental principles and practices, we'll recall that site reliability engineering, or SRE, is a specific set of practices developed at Google and since embraced everywhere that hold user happiness and appropriate reliability at scale as their ultimate objectives. One of the major areas of focus for both the more generalized DevOps movement and SRE, which is a specific implementation of it, is the focus on automating as much of the repetitive manual tasks that specifically don't add enduring value as possible. Ultimately, our objective is to achieve the appropriate level of reliability for our services and maintain that level, even as user demand and load increases, without having to proportionally scale the staff required to support that service. This is really the ultimate value of focusing automation. It allows us to reach much greater levels of scale. And this is, of course, a very simplified version of the answer. You can find much more detail on why we focus on reducing toil in the books we've published on the topic. I would particularly encourage you to review Chapter 5 of the first SRE book called Eliminating Toil, which discusses this in much greater detail. So now that we've covered the value of automation, let's talk about what we mean when we say that we want to treat something as code. Here are the things we'll be looking to accomplish. A lot of this comes from the infrastructure as code principles, but there's no reason why we can't think of monitoring as code using the same exact language. So first, we want to be able to accurately determine if there are any differences between what we want to be the case in our monitoring configuration and what is actually currently the case. And so to that end, we need a way to precisely specify the desired state and be able to retrieve the current state. Next, we want our work to be reusable. We want to be able to create modules and components that other folks can use. And again, we're in pursuit of scale here, and that can't happen if every service team has to build this from scratch, especially in a model where SRE is a shared service across multiple service teams. We want to use a declarative approach to specifying our desired state. This means we want to define the state we want, not the set of actions to take to get there. Now, one of the benefits of this approach is that it's idempotent, which means that we can run our automation no matter what the current state is and still be sure we'll arrive at the correct end state. This is different than an imperative approach where we specify the exact steps that should be taken. That might work best for programming, but not for configuration. And finally, in part because we are SREs who value software engineering practices, we want to treat these configurations in the same way we treat other source code. One important thing we want to achieve is the other side of the reusability coin. We want to both share our work and enable others to collaborate and contribute to it. And this is where code management is incredibly important. So I hope that you're now convinced of the value of automation in general and applying as code principles to configurations specifically at this point. The next logical question is, okay, how should we get started? What can we actually automate? So in Google Cloud Monitoring, there are 4 primary entities whose creation, updates, and deletions can be automated. The first 3 are available today, and that's where most of our focus will be. They are Uptime Checks. So this is a feature of cloud monitoring that allows you to configure synthetic checks to validate things like URL availability, website performance, and TCP connectivity on VMs. Alerting policies. So I'll get into their details in a bit, but these are how you configure cloud monitoring to actually send alerts and notifications when specific conditions are met. And finally, dashboards are collections of charts folks use to visualize the state and health of their systems. When looking to automate Google Cloud Monitoring configurations, you have 3 primary options. The first option is to use either the Google Cloud APIs directly or make API calls in your code using client libraries provided by Google or third parties. This works very well if you have a robust software engineering practice, and you may need to include monitoring automation in larger scripting or automation projects. Your second option is to use Google Cloud Deployment Manager. This is a fully managed and hosted service provided by Google. It uses YAML as its declaration language, and the current state of your configuration once you apply is then stored in the cloud. You can interact with Deployment Manager using gcloud commands or its own APIs. And then your third option, and the one I'll be using for our examples coming up next, is Terraform. This is an open source toolkit provided by HashiCorp. It uses its own language for declarations, but it has excellent multi-cloud support, which is important for many users. The open source version, which is what I'll be showing you today, stores state locally in .tf state files. So these can be checked into source control, just like the main configuration files. So I imagine by now this is probably enough theory for everyone. Let's get into some specific examples. Let's start with a simple example of creating an uptime check. As you may recall, uptime checks are used to measure web service or TCP endpoint availability and latency. Here's what our Terraform file looks like. There are 5 things to note here. First, at the very top, we specify the provider to let Terraform know that we're working with Google Cloud and to provide the project we're operating in. Next, we define the resource. It's an uptime check. In the HTTP check section, we specify the path and port to connect on and whether or not to use SSL. In the monitored resource section, we specify that we're checking a URL rather than a TCP endpoint, the host we want to connect to, and the project where this uptime check will be created. And finally, we specify a content match string we want to validate in the response. In the terminal, we run the Terraform plan command. It will validate our configuration, compare it against the current state if there is any, and determine what resources need to be updated. Here, the plan is to add one new resource, as you can see in the output at the bottom. Once we've confirmed that the plan is correct, we issue the Terraform apply command. It'll once again provide the plan and ask for an explicit confirmation. It will then provide the specific resources that were created, changed, or deleted as a result. And there we are. We can now log into the Cloud Console and validate that our uptime check has been created. If we want to clean up what we did, we can issue the Terraform destroy command. Similarly to apply, it will create and validate the plan of action. It will then ask us for a confirmation before actually destroying the resource, and then let us know when it's done. And now we're back to a clean slate. Let's take a look at another slightly more complex example. Once we've created an uptime check, we may want to get alerts if and when it fails. Before we get into the code, let's review the basics. We're going to create an alerting policy, which combines both the condition to be evaluated to trigger notifications and the mechanism to be used for the notification itself, called the notification channel. Our Terraform code needs to describe both of these. So here's how we would configure the policy in the UI. We would use uptime check URL as the resource and the check passed as metric. We would then filter it to just the check we care about. We would use the count false aggregator to count how many of the locations from which the check is running report failures. Our condition would then trigger if any failures are reported within 5 minutes. Here's how we would write Terraform file to represent that. Note that we specify the notification channel first with type email and an email address where the alerts would go to. The output would then is stored in the variable. We then define our actual alert policy with a condition threshold. There we provide the metric filter, the comparison operator, and the correct aggregations. And then finally, we specify the notification channel we've created up at the top using the variable all the way at the bottom. When we run Terraform plan, we see that it's actually going to create 2 resources, the notification channel and the alerting policy that is going to use that channel. When we run apply, we see that 2 resources are created as we expect. As before, we can confirm that our alerting policy was created in the console. We can also confirm that the correct notification channel was created and that our policy is using it. If we want to undo what we've done, we can again issue the Terraform destroy command. Note that this time, 2 resources are destroyed. Terraform is aware of the dependencies involved and destroys the alerting policy first and then removes the notification channel. I hope this served as a good introduction to the practice of monitoring as code and how to use Terraform to automate configuring Google Cloud monitoring for your projects. At this point, I'll turn it over to Pod to talk about how the SRE team at Schlumberger put these into real-world practice.
Thank you, Yuri. So I'm going to talk to you about Schlumberger's monitoring as code journey over the past 2 years, starting with 2018. In Schlumberger, there are many solution teams developing apps and services for the Delphi ecosystem, and each one of these teams was creating their own version of the monitoring framework. What I mean is they were creating dashboards or alerts or even log-based metrics in their own silos using different coding languages, or in some cases just configuring through the UI. In terms of the big picture, it was obviously great to see so many teams taking monitoring so seriously. But the problem was with this approach that very little code was being reused, which led it to be hard to build any best practices or learnings. And in most cases, word of mouth or presentations were the only way of showing what each of the teams were doing. So what changed in 2019? Well, a new central SRE team was created, and it's the team that I work in today. The purpose of this team is to provide governance and alignment across the various solution teams in Schlumberger. At the beginning of 2019, we started brainstorming of what we kind of wanted to focus on for that year. And after reading various books on SRE from Google, we decided it should be toil management. After attending many presentations and demos of each of the monitoring frameworks from each of the teams, we wanted to merge the implementation learnings into one toolkit. So the idea of creating one toolkit or one framework, we believe it would allow us to add new monitoring capabilities that would benefit all the teams using it. One example of this was when Google introduced the service level monitoring APIs last year. We could also ramp up new solution teams much faster with the use of this toolkit within their apps or services. And by using the one toolkit, we could spread the message of how we wanted to monitor systems across Schlumberger more consistently. So the fun part, creating the toolkit. So what did we do? By taking the best bits of each of the solutions monitoring scripts, we created a toolkit to work with the Google monitoring endpoints. Key to the design of the toolkit was to understand that most teams already had monitoring set up, either through the code or through the UI, and we want to take the approach of backing up and restoring. Backing up the aspects of monitoring that they care about in the form of JSON files using protobuf, and providing the ability to restore from them. Once we created the toolkit, we needed a way of teams to adopt it, because there's no point having a toolkit that no one uses. So we created a second Git repo which they could fork from to get started. And both of these Git repos are an image in this slide. Within the Git repo, we provided the necessary pipelines to take our approach of backing up and restoring. We also provided the monitoring controls that will need to be in place for all of our GCPs for SOC 2 compliance. And we also included other examples of how to monitor different Google Cloud technologies, such as PubSub, Google Storage, Data Store, Google Load Balancer. And for the teams that were new to SRE practices, we also included examples of how to set up SLIs and SLOs. Within the Git repo that the solution teams had forked, they could also add their monitoring configuration that was specific to their app. We inner sourced both of these Git repos so that teams could contribute new features, fix bugs, or even provide good examples of monitoring certain aspects which the other teams may benefit from. Each of these Git repos are managed through pull requests, which our team approve, because we have the broad knowledge of how all the other teams are using the toolkit, and we can give advice on the best ways of monitoring certain aspects of Google Cloud. Having everyone on the same toolkit gives us the agility to be more dynamic with either new technology adoption or compliance requirements. So what are the key takeaways from our learning of our implementation? I would ask you to go and look at the Google Git repo in GitHub. There you would find examples of how to back up your alerts using Python. And I think this would give you ideas of how to add monitoring as code into your organizations. So where are we today? We believe that within your organizations, you can start by implementing the following points that are shown in this slide. And within our organization, by consolidating into a single toolkit or framework, I'm going to explain to you how we have benefited by doing this. Number one, new solution teams are no longer reinventing the wheel. The learning curve is less steep and the time spent is significantly reduced implementing monitoring. Number two, monitoring is no longer an afterthought. The automated deployment allows the solution teams to implement monitoring early in their product lifecycle, enabling them to have the insights into the reliability and performance of the critical user journeys and metrics that they've defined in their projects. This will also improve the solution's overall reliability at the time of launch. Number three, continuity and continuous improvement is achieved using code, rather than having to update multiple different documentation sources. And lastly, point number four, the central support organization has a consistent interface for monitoring, alerting, and reporting across the various solution teams, both for operational and business level needs. This is an example of our service level objectives compliance dashboard that we created in-house. This gives us a single pane of glass for both business and solution teams on how well our apps and services are performing. Each of the colored boxes represents whether a solution or shared service is either in compliant, non-compliant, or possibly even in feature freeze. And with that, I'd like to thank you for listening to me today, and I hand it over to Yuri.
Thank you very much for that. It was hugely informative. I really appreciate you being here today. And thank you to everyone for watching. We hope that we found this useful, and we certainly would encourage you to get started with your own journey toward monitoring as code. Thanks again. Take care.